What if the secret to powerful healing lies hidden in the chemistry of plants? Today we'll explore the fascinating world of coumarins and lignans, two groups of plant compounds with remarkable pharmacological effects. Let's embark on a journey through the chemistry and healing power of coumarins and lignans. We'll start by understanding coumarins, explore their pharmacological actions, then dive into the world of lignans and their role in herbal medicine. To appreciate the power of coumarins, we first need to understand their chemical structure, how they're formed, and where they're found in nature. This foundation sets the stage for their diverse pharmacological effects. Before we dive deeper, let's clarify what coumarins are and why they matter. Coumarins are lactones of cinnamic acid, specifically benzoalpha-pyrones, formed via the shikimic acid pathway and characterized by a cyclic C6-C3 skeleton. This unique structure is the key to their biological activity. Here's how coumarins stand out: their chemical structure, how they're formed, and where they're found in the plant kingdom. Chemical structure is central to coumarins. They are lactones of cinnamic acid, known as benzoalpha-pyrones, and feature a cyclic C6-C3 skeleton. Formation pathway refers to their synthesis through the shikimic acid pathway, a common route for many plant secondary metabolites. Natural occurrence means coumarins are widespread in nature, present in foods like tonka beans, celery, parsnips, carrots, and various medicinal herbs. Notice how these coumarin compounds differ in their chemical groups and natural sources. Each brings unique properties to herbal medicine. Umbelliferone has a hydroxyl group at position 7 and is found in various plants. Herniarin features a methoxy group at position 7, commonly found in Herniaria species. Esculetin contains hydroxyl groups at positions 6 and 7, present in horse chestnut. Scopoletin has a methoxy group at position 6 and a hydroxyl at 7, found in black haw. Now that we know what coumarins are, let's explore their pharmacological actions. These compounds have a range of effects, from anti-inflammatory to anti-cancer activities, making them valuable in herbal medicine. Here's how coumarins exert their therapeutic effects: anti-inflammatory, anti-edema, anticoagulant, and photosensitizing actions. Anti-inflammatory action is achieved as coumarins inhibit prostaglandin synthesis through the cyclooxygenase pathway. Anti-edema effects come from coumarins' ability to improve lymphatic drainage and enhance the breakdown of extracellular protein. Anticoagulant properties are seen in dicumarol, which inhibits vitamin K and prothrombin, slowing blood coagulation. Photosensitizing effects are due to furanocoumarins, also known as psoralins, which can increase sensitivity to sunlight. Let's compare some common coumarin-containing herbs and their main actions. This helps us see how each herb can be used therapeutically. For main coumarin, Angelica archangelica contains furanocoumarins, Ixialis hippocastanum has esculetin, Apium graveolens features bergaptan, and Petroselinum crispum contains both bergaptan and psoralin. In terms of key actions, Angelica is spasmolytic and digestive, Aesculus is venotonic and anti-inflammatory, Apium is anti-rheumatic and diuretic, while Petroselinum is a diuretic and urinary antiseptic. Regarding safety, Angelica should be used with sun exposure caution, Aesculus avoided in renal or hepatic impairment, Apium contains essential oils, and Petroselinum's volatile oils require careful use. Coumarins are used in clinical practice for their anti-cancer potential and a variety of other therapeutic effects. Anti-cancer potential is significant, as coumarins target multiple cancer pathways, including kinase inhibition, cell cycle arrest, and angiogenesis inhibition. Other uses include spasmolytic effects, estrogenic activity, improving vascular integrity, and even serving as sunscreen agents. With coumarins covered, let's turn to lignans. We'll look at their chemical structure and where they're found in the diet and herbal medicine. To understand lignans, we need to define them clearly. Lignans are a class of plant secondary metabolites with a basic structure derived from phenylpropanoid units, often exhibiting phytoestrogenic activity. This definition highlights their chemical origin and biological significance. Here's what makes lignans unique: their chemical structure, phytoestrogen activity, and presence in everyday foods. Chemical structure of lignans is based on phenylpropanoid units, forming the basic lignan skeleton. Phytoestrogen activity means that some lignans can mimic estrogen in the body, influencing hormonal balance. Dietary sources include flaxseed, chia seed, and most seed coats, making them accessible through common foods. Notice how lignan content varies across different foods, with flaxseed leading the way. Flaxseed contains about 370 milligrams of lignans per 100 grams, making it the richest source. Chia seed is also a good source of lignans, though specific values are not provided. Other seeds contain lignans, mainly in their seed coats. Now, let's see how lignans are used in herbal medicine. We'll explore their pharmacological actions and the herbs that contain them. Lignans offer antioxidant, anti-cancer, and neuroprotective actions, making them valuable in herbal medicine. Antioxidant action is seen in compounds like schizandrin B, which protect against oxidative stress. Anti-cancer effects are notable, with some lignans showing potential to reduce or destroy certain cancer cell lines. Neuroprotective properties mean that certain lignans may help prevent neurodegenerative diseases. Let's compare some important lignan-containing herbs and their main pharmacological actions. This highlights their diverse therapeutic roles. For main lignan, Schizandra chinensis contains schizandrin B, Magnoliae officinalis cortex has magnolol and honokiol, and flaxseed provides seco-isolarchiresinol and maturisinol. In terms of key actions, Schizandra is antioxidant and potentially anti-cancer. Magnoliae officinalis is antioxidant, anti-inflammatory, and neuroprotective, while flaxseed is phytoestrogenic and antioxidant. Clinically, Schizandra supports liver health and may reduce cancer risk. Magnoliae officinalis is used for multiple organ systems, and flaxseed supports hormonal and cardiovascular health. Magnoliae officinalis contains multifunctional lignans like magnolol and honokiol, which contribute to its wide range of medicinal uses. Magnolol inhibits lipid peroxidation, acts as an anti-inflammatory, and offers cardiovascular protection. Honokiol inhibits thrombosis, induces apoptosis in cancer cells, and has neuroprotective effects. The chemistry of coumarins and lignans reveals the deep connection between plants and human health. Nature's molecules, like coumarins and lignans, continue to inspire modern medicine, reminding us that the answers to many health challenges may be found in the plant world.